Here is an example for exponential decay. The question reads, the half-life of silicon-32 is 710 years. If 40 grams of silicon-32 is present now, how much would remain in 200 years? Now, in order to solve any word problem, it is always best to note down the given information from the question. So we have here, let me write that down, the half-life, let's call this T1. Now T1 equals 710 years. Then we have been given the initial amount. Now the initial amount is usually denoted by the letter N0, and that's given as 40 grams. Now we have also got the time given. Now let's call this time T2. Now T2 is 200 years. The next step is to note down the standard formula. In this case, we will be using the exponential decay formula. Now at times there will be problems where we use the growth formula, and there's just a slight change between decay and growth. Now in this case, you will note that the formula has got a negative sign. Let me write that down. N equals N0 into e to the power minus kt. That's negative kt. So this is for decay. Okay. Now N denotes the final value of a radioactive substance. In this case, it's silicon-32. N0 is the initial amount, and the amount of this substance has already been given to us in the question. So this is our initial, and K is the decay constant. Now like I mentioned, it could be a growth constant as well. And we also have the time T. Well, T obviously denotes the time. Okay, so this describes the entire formula. We now need to formulate the next equation using this formula. Now since we have the initial value as 40 grams, let's substitute that and note down the equation. So that's N equals 40 times e to the power minus kt. Okay, let's consider next the half-life time. So at T1 equals 710 years. Okay, so this actually implies that after 710 years, the element silicon-32 reduces by half its initial value. That's why it's called half-life. It reduces its amount by half. So here 40 grams becomes 20 grams. Okay, so this 20 grams is our final amount. So it starts with 40 and then it reduces by 20 in the period of 710 years. Now that we have this, let's note down the values we have so far and calculate the decay constant K. So we have N, which is the final amount of 20 grams. N0 is the initial value given, which is 40 grams. And the time T is 710 years. All these values need to be plugged into the formula we wrote earlier. N equals N0 times e power minus kt. So substituting the values, that's 20 equals 40 times e power minus 710 k. Okay, so we're solving for k, please remember. Now we will have to divide both sides by the constant 40. By doing so, we are isolating the exponential term on the right side. So dividing both sides by 40. Now let's see what that gives us. So we now have 20 divided by 40 equals 40 times e power minus 710k divided by 40. So on the right side 40 cancels out, and on the left hand side 20 by 40 is reduced to 1 by 2. So this is now our equation. Okay, here is where we use logarithms. For the next step, we apply ln on both sides. Now it is important to note the type of log term we use here. Because we have an exponential term on the right side of the equation, we are going to use ln. So that's applying ln on both sides. Now ln is log to the base e. Okay, so let's see what we have here. ln of 1 by 2 equals ln of e to the power minus 710k. Okay, here on the right side, ln and e cancel each other out. So when that happens, we are left with the exponential part of the term, negative 710k. So we now have ln 1 by 2 on the left equals negative 710k. Now ln of 1 by 2 can be found by using a calculator. So the value is negative 0.6931. Okay, so this equals negative 710k. Okay, now we can isolate k by dividing both sides by negative 710k. Oh, negative 710. So dividing both sides by negative 710. We always divide by the constant that's next to the variable, so that's why we divide by negative 710. So now we have k isolated as negative 0.6931 divided by negative 710. Now we know for a fact that two negatives make a positive, so our value of k will be positive. So k equals 9.76 times 10 to the power minus 4. Okay, so that's our value of the decay constant. Now we still have one more part to work on. We have to find out the final value, right? So now we're going to take into consideration the next time period given in the question. T2 equals 200 years. Now what do we have? We need to find out the final value n. So that's a question mark. We have our initial value n naught as 40 grams. We have our time. This time it's 200 years. We also have the value decay constant k, which is 9.76 times 10 power minus 4. Now the formula we wrote earlier is very, very useful. So in this case, we are going to plug in all these values into the same formula that we wrote earlier. And in order to find out the final value of silicon 32, let's plug all these into the formula n equals n naught e to the power minus kt. Okay, so we have n equals 40 times e power negative 200 times 9.76 into 10 to the power minus 4. I hope this is visible to you all. Okay, so now we are going to multiply the numbers in the exponent. That's 200 times 9.76 into 10 power minus 4. So that's n, let me just write that down, equals 40 times e to the power negative 1952 times 10 to the power minus 4. Now if we have to write this down in simpler terms, it would be 40 times e power minus 0.1952. Now e to the power minus 0.1952 can be written as 0.8227 using a calculator, and further we multiply these two terms to get 32.90 grams. So the final value of silicon-32 after 200 years is 32.90 grams. Now that's it. Thank you for watching.